Hello everyone, welcome to my channel Chemistry is Fun. Today we will do the chapter Solutions. This is part 11. This is for class 12 CBSE. Today we will study about depression of freezing point. Now see, whenever there is lowering of vapor pressure of a solution, it causes a lowering of the freezing point compared to that of the pure solvent. Okay. At the freezing point of a substance, what happens is that the solid phase is in dynamic equilibrium with the liquid phase. Okay, solid phase will be in dynamic equilibrium with the liquid phase. And now what is freezing point? The freezing point of a substance is the temperature at which the vapor pressure of the substance in its liquid phase is equal to vapor pressure in the solid phase. So the two things we consider are liquid phase and solid phase. Depression in freezing point will be given by delta Tf, that is equal to Tf naught minus Tf. Tf naught is the freezing point of pure solvent. Tf is the freezing point when non-volatile solute is dissolved. So Tf naught minus Tf gives delta Tf, which is depression in freezing point. Now depression in freezing point for the dilute solutions is directly proportional to its molality. That is, delta Tf is directly proportional to m. To remove the proportionality sign, we multiply with a proportionality constant. So delta Tf is equal to Kf into m. This proportionality constant Kf is known as the freezing point depression constant or cryoscopic constant. Now if W2 grams of the solute, which is having molar mass M2, it is present in W1 gram of the solvent and it produces a depression in freezing point equal to delta Tf in the solvent, then we can find out molality of the solute. Molality of the solute M is equal to W2 by M2. What is W2? This is gram of the solute and M2 is the molar mass, divided by W1 by 1000. W1 is gram of solvent, W1 gram of solvent divided by 1000. So, but delta Tf was Kf into m. So, this m is there, we multiply it with Kf. So, delta Tf equal to Kf into this full thing we write, what we got here, m. Delta Tf equal to Kf into W2 by M2 divided by W1 by 1000. So on rearranging, M2 goes to the denominator and then 1000 will go to the numerator side. So we get Kf into W2 into 1000 divided by M2 into W1. Now this delta Tf and M2, we can change the positions. We get M2 equal to Kf into W2 into 1000 divided by delta Tf into W1. See, from this equation only we get this one. Only we are exchanging the M2 and delta Tf. So we get M2 equal to Kf into W2 into 1000 divided by delta Tf into W1. Based on this, let us solve one numerical. So let us solve. 45 gram of ethylene glycol is mixed with 600 grams of water. Calculate the freezing point depression and freezing point of the solution. So first of all, we have to find out molality. Molality of the solution will be moles of ethylene glycol divided by mass of water in kg. So moles of ethylene glycol, it is given 45 grams. So for the mass, what we do, W2 by M2 we have done. So W2 is what, 45g divided by 62. 62 grams per mole. From here we get 0.73 moles. This is the moles of ethylene glycol. Mass of water in kg, they have given in grams, we divide by 1000. So it is 600 gram divided by 1000 gram per kg. In 1 kg there is 1000 grams. So from here we get 0.6 kg. Molality of ethylene glycol will be 0.73 divided by 0.60 kg, that is 1.2 moles per kg. So delta Tf will be, delta Tf is equal to Kf into m. So m we have got here and Kf is 1.86 Kelvin kg per mole for ethylene glycol. So delta Tf equal to 1.86 Kelvin kg per mole into 1.2 mole per kg. So from here we get 2.2 Kelvin, that is delta Tf. 2.2 Kelvin is delta Tf. Freezing point of the aqueous solution will be 273.15 K minus 2.2 K, that is 270.95 K. 270.95 K. This is the final answer. I hope students you all could understand whatever I discussed today, and also I hope you all could understand the numerical. Thanks for watching my video. Please subscribe to the channel and share the video. Thanks for watching. Thank you all.